Hi, I'm David with EV World News. We're talking about electric vehicles, green energy, and the stock markets. And today I'm back with our founder and chief editor, Bill Moore, as well as a special guest, Richard Phamdo from Voltaic Marine. How's it going, Richard?
Good, guys. Appreciate you having me on the show.
Yeah, so we like talking about things other than cars all the time. Okay, because it's invariably, there's another new electric vehicle. It used to be there was only like a couple of electric vehicles in the world, but for a long time there was one, and then it would go out of service, and then another one would come along, and then this year we were just talking.
32.
There's 32 new models for this year.
Wow.
for the U.S. market. I mean, it's not counting like BYD or somebody like that. It's just the U.S. market. And but we sometimes will do episodes on electric planes. We've discussed electric trains, big ships. Yep. But here we're here to talk about boats, right?
Oh yeah, that's what we do. Well, we have a lot of stuff we're doing, so we can dive into that too. So
nice. So how did you get involved? Tell us a little bit of the background story of Voltaic.
Yeah. So I was in Silicon Valley for 14 years. I worked at Intel. I was in the automotive division, actually. So you talk about electric cars. That's actually where I came from. I was in the division that was basically putting semiconductors into electric vehicles. We had parts in like software-defined vehicles, infotainment, connectivity, battery management, kind of snowballed from there. And other systems that I've worked on is grid scale, battery energy storage. I've worked on semiconductors in AI training data centers, factory automation, kind of across the whole gamut of like putting semiconductors in an electric vehicle all the way to the factories that produce them, to the data centers that train them for autonomy. And I've worked with a lot of the players in Silicon Valley in California. So my original background is basically semiconductors for electric vehicles and autonomous vehicles. And through that kind of process and career, I gained a lot of, good, solid contacts and friends in the industry. And kind of throughout the process of having just informal lunches and dinners, I started talking about like, hey, everything we're doing, in the electric vehicle market and autonomy market is so mature nowadays that there's other segments that are starting to populate from these things, right? And you even mentioned like eVTOL started to kind of come after electric vehicles, who started proving the battery architecture, the powertrains, the software, and the people were putting them in flying things. At the time that I was thinking about this, I didn't see a lot of marine entries, and I'm a big personal boater, so to me it just kind of made sense. Like, hey, all this stuff is mature, very good supply chains, very good chemistries, a lot of R&D. There's billions of dollars have gotten electric vehicles where they are today. We're putting them in planes. Let's go put them in boats too, because that's another good use case that's starting to reach the power density requirements of where we're at today in the technology that makes sense for mass adoption in the market. Then that spurred into, talking to colleagues, some of my industry contacts. People started to jump on board, do some work on the company. Then eventually we started leaving our jobs and growing the team. And now we are all full-time and have, a good size team that's working on this, getting products out to market.
Nice. So, your boats are, they appear to be mainly in the recreational space. Is this correct?
Publicly today. Yeah. So we're building our technology stack very similar to how, Bill and David, you've probably seen the industry, right? When we first went through this electric kind of mass adoption in our current generation, there was a lot of debate about how do you go build the vehicle differently to optimize basically energy density of the vehicle platform, right?
Right.
And what happened is car companies started adopting like the skateboard concept. They were like, hey, we need to do away with the whole chassis and we need to redesign the chassis around the battery pack so we can get enough battery so that people won't have range anxiety and we can meet 300 miles of range in these things. And that, I think, was kind of the simple, brilliant unlock for the land vehicles, where once you started to think like, hey, this has to be a ground up vehicle design specifically around the propulsion stack, that's when we got to these ranges that the industry obviously is now adopting more at mass scale. And we're building our architecture the same way. So when we build boats, we design all of our boats from ground up. We design our boats around a powertrain and the battery stack. We build our batteries specifically for marine applications. We actually build our batteries to be able to scale into every single boat where we're going to make. And that's how we start building that platform concept into this industry, improving it out in our own segment, in our own brand under consumer. And we'll be launching more things this year about how do we take that same stack in powertrain software and integrate that into different boats in completely different use cases. So mid this year, you'll see another industry announcement from us about us using everything that you see in this boat into a very different application, but it will all be the same stuff, the same battery and software.
Yeah. So these are monohulls you're doing?
Yes. This specific design is a monohull.
Okay.
It's a deep blue monohull.
Are you looking at hydrofoiling these, or are you sticking just simply with getting it up, on the wave?
Yeah, it's very boating is very interesting because your question, Bill, there's a lot of different use cases, right? So you have monohulls, pontoons, tri-hulls, hydrofoiling hulls, and every time you kind of go a different route, it really changes, obviously the running surface of the boat, but also the internals of the boat, and then also the different requirements. So for our first boat, this is meant to be a mainly kind of a U.S. consumer model where these boats mainly are monohulls because these boats are meant to actually engage with the water and shape a wave so people can do water sports.
Okay.
And in that use case, it's not really applicable for hydrofoiling. But we have our own thoughts about how we could optimize specific hydrofoiling boats for different use cases. Won't really dive too far into that, but our philosophy is we design the boat to maximize its performance for its intended use, bar none, period. And this one is absolutely maximized for its use, which is a water sports boat.
Okay. Are you guys using a sort of an inboard-outboard type propulsion system? You're using jets? What are you doing there?
We were fortunate enough to be able to go direct drive on this model. And I say fortunate because kind of the gasoline version of this typically takes a motor, faces it backwards. They go through what they call a V drive. And that means there's a transmission and gearbox and then a V drive portion. But you have a lot of it's the kind of benefit in electric is you can minimize, a lot of those mechanical hops to maintain efficiency. So by going to direct drive, we have the motor, attach a coupler to the shaft, a lot of efficiency gained by cutting out gearbox and transmission, a lot of maintenance improvement because we have no oil change in the whole boat. There is no gearbox that needs oil. There's no transmission. It's just literally 3 parts. It's a motor, a coupler, and a shaft.
Right. And
then it goes to the prop and the rudder, obviously. But that simplifies a lot of the powertrain in this. And we're finding that specifically in electric boats, electric motors are amazing at low-end torque. We get the maximum torque at 0 RPMs, right? But the other thing that happens is propellers usually don't even need that much torque because they're spinning through water. And if they have too much torque or too much speed and not the right pitch or couple, whatever it is, they start to cavalcade, meaning they actually don't push the boat through the water. It just starts to create a whole bunch of chatter. So what we're finding is we're also able to do a lot of things on how we engage the motor to the shaft of the prop and use different props to increase the efficiency of the energy we're getting out of the powertrain, directly translating to movement on the water through the prop.
So what advantage? So you're doing aluminum hulls instead of fiberglass, right?
Yeah, I think, we're kind of going against, I'd say, the norms. A lot of the kind of consumer boats in the U.S. are fiberglass based. A lot of the more commercial fishing boats are usually aluminum based for other specific properties. We are focused on aluminum construction for all of the foreseeable models we're actually launching. And there are technical reasons we like that, but there's also some other things. And happy to dive on material selection too if you're interested. We always get a lot of healthy debate about that from boat makers about why did you choose aluminum versus fiberglass, yada yada yada.
Okay. I've got a question from somebody. Does it still require a flexible, it says company between the motor and the shaft to prevent catastrophic failure. Might have been coupler.
I think he said it. Well, go ahead.
Yeah, that might be a flexible coupler. So a lot of electric vehicles do this. They have kind of like a buffer built into the coupler, where like if you take impacts on the shaft, right, or the prop, there's literally like kind of like a rubber coupler, or let's say like buffer between both sides of the coupler that take the brunt of that, protect the motor. I think that might be the question, but that's one way to solve it. The other thing with I think boat propulsion is you have different material even through that stack. So your motor's, the motor. The shaft is usually a harder type of metal, and then the props themselves are a very soft metal. So if the prop hits something, the prop's going to bend before it affects the shaft, and that's usually intentional. So you have kind of multiple mechanical layers that you try to protect your motor for those things.
Okay. So one of the things I noticed, you've got a massive battery pack on this. It's 300 kilowatt hours. Is that correct?
Yeah.
Okay. So that's about triple what cars have, or more, 3 to 5 times what cars have. So, how did you, tell me a little bit about that. What kind of challenges did you have with putting that big of a battery in this thing?
Yeah, we intentionally did that because when we were going to market, we still found a lot of customers were concerned with range anxiety in this market. And this specific use case, pushing a boat through the water, if it's not a hydrofoil, is a very demanding powertrain workload, because you're literally pushing something on top of water surface. And the way that you're doing that is usually through a propeller, which is very small compared to the surface, area of the boat. So it's almost like the equivalent demand of basically towing something uphill is what the powertrain needs to support, because that's essentially what you're doing. From a powertrain perspective, it takes a massive amount of energy. That's why some of these boats have 80 to 100 gallon fuel tanks.
Right.
So the range anxiety challenge is more extreme, I'd say, in the consumer boat market or the industrial consumer commercial stuff, meaning that we wanted to come out to market with something that the electric vehicle land-based companies, their first charter was to prove and solve range anxiety, meaning we needed to have a massive amount of energy, 3 times that of a typical land vehicle, because it is the equivalent of essentially towing uphill on a powertrain. So by doing that, we had all of our duty cycle calculations. We're like, hey, what do people use these boats for in a day, to the point where they'll be comfortable doing that and not feel like they're getting range anxiety. We built our powertrain around that. We selected the battery size around that. We built the battery around that. We built the boat around that. So our real goal of this model is to prove that electric is here and can perform a full day of activity at one of the most demanding electric powertrain use cases on the planet, which is actually boats. That's
what are the dimensions of the boat here? It looks like it's probably 30 feet long, 20 to 30 feet long.
This is a 24-foot model.
Okay.
It's less than 8 feet wide. And that's all because these are typically trailer boats in some cases. Okay. So there's legal requirements on the road that they stay within to fit on a trailer.
Right.
We made this so it's the most usable in the U.S., whether you're leaving it in your slip or whether you're towing it across the country or towing it to the lake every day. So it fits kind of within that 25 feet maximum length and 8 foot wide.
What does this thing weigh on a trailer?
We will be around 7,000 on a trailer, with about 1,000 on a trailer in production, because we want to keep the full package under 10,000 pounds, because most of the entry-level trucks in the U.S., including the electric trucks, have a typical towing capacity of 10 to 12,000 pounds.
Right. Yeah. That's still not, considering you got a 300 kilowatt hour battery, 7,000 pounds really isn't that much. That seems pretty light. If you were in a vehicle, a car with that kind of size, you'd probably be 15, 20,000 pound kind of vehicle, because it'd be a truck of some sort, like a cement truck or something.
So how do you've got these batteries, which makes great ballast. I assume the boat, the engineering of the boat, the nautical side of it takes that into consideration? How are they kind of laid out, or is that proprietary?
The battery layout in the boat is proprietary. We've also been fortunate enough to be awarded a patent on how we've designed the boat and the battery system. As I mentioned, this was a platform type of engineering exercise, not necessarily a one boat model. So when we built it, everything inside of this boat is built to scale. So we have one of the batteries, 150 kilowatts is down kind of the rear to the middle of the boat. And we did that for weight displacement. So you have an equal weight displacement going down to the front of the boat. And then the next 150 is actually in the rear of the boat. And we have two packs connected in parallel to achieve that. But that gives us nice weight distribution, the total 300 kilowatts we're looking for. But also something we talk about a little bit in the technology page is we have two battery packs. So we can use two battery packs and get 300 kilowatt hours together, or we can use one and get 150 kilowatts. And when I say platform, that means we can build a lot of different boats all the way from 300 kilowatt hours to 150. And we're always going to focus on maximizing our architecture for the use case and really always focused on range anxiety too in our first few generations of boat models. So that's how we become a flexible platform, be able to basically have two different battery configurations, if not 3 to 4, depending on how you connect them.
So you got 570 horsepower in this boat too. It seems strong.
Yeah, and that's because the horsepower demand equivalent, like in kilowatt hours continuous, is really demanding in the boats of like this category. So one of our key engineers is actually the founder of the motor company we're using. We've been fortunate enough to know him through personal networking. The team literally works out of his shop at his personal residence today. So it's been a nice way where you have. I think that I might have been on mute. Yeah, we have the guy who literally kind of founded the company with the powertrain components we're using, working directly with our engineering team on integrating it together nicely with the battery.
So when you said you were involved in boating when you were back in Silicon Valley, was that on the San Francisco Bay or the Sacramento River or out in the Pacific Coast? What kind of boating were you doing?
Yeah, I was doing actually this type of boating. So, in my professional life, I was a semiconductor guy working with electric vehicle companies and robotaxi companies, helping them deploy hardware at scale. And then in my personal life, I purchased these type of boats. This is what me and my friends and family do. It's what we take our kids out on. So this is a very kind of American pastime type of boat. And there's a good marriage between the technical requirements of this type of boats, but also my personal experience. So I knew what these customers were looking for. I knew where the gaps were in the industry because I've bought in a lot of these type of boats. But then, Bill, you've already asked the good questions. Like these type of boats like ballast systems, and having static ballast is actually very different in the experience of using these type of boats instead of water ballast systems. So we've mixed a lot of things together that kind of have a healthy technical alignment.
Okay. So you were interested more into getting into wake boats or something you could putter around the bay in?
Oh, we're interested in everything. So this is just kind of our first entry to prove, at one of the highest horsepower demanding consumer boats in the market, we can meet the range expectation and the power demands. And then after this, you'll see more models prove that same approach is applicable to very different use cases. So whether it be puttering around the bay, eventually maybe we'll get in hydrofoils. We'll be kind of releasing like a commercial type application mid this year for long duration sea stuff, all basically on the same core architecture we started here.
Okay.
Yeah, I see on your website you mentioned some stuff for defense. What are your thoughts for an electric boat in the defense space? Use cases.
Yes, I think it's always it's always technical alignment. So, one thing that I think the electric vehicle industry also went through was like when they first came out, people started comparing electric vehicles to gas and diesel, and then seeing where the overlap and the gaps are. And, that same thing I think is happening in the EV boat space today. And one thing that's really good about electric is very high torque at low RPM demand. Absolutely will outclass combustion engines there. That's just kind of inherent with that powertrain. The other thing that's really good is very low acoustic signature, very low thermal signature. Also the ability to recharge at sea via mechanical or photovoltaic means. So if you look at like the technical, pair all the best technical advantages of electric powertrain and put that into like a commercial or defense application, and some things will just inherently be a better use case for it there. And that's what we're going to always focus on, whether it's even in the consumer space, commercial defense, is pairing the most advantage of the powertrain with kind of the most advantage in the use case. And that's what we'll be looking at and releasing.
Well, we've seen in the war in Ukraine how they've used electric bikes because electric bikes are silent. Yeah. And there's been some real advantages to things like that. So obviously a quiet boat with no heat signature would be certainly a lot harder to detect at night.
Yeah.
We also have zero water intake to cool the system. So most boats always have to take in fresh water from the ocean or the lake to cool their system, whether you're at sea in the lake. We have zero of that. That makes it also very interesting because you don't need that pipe. We also don't have exhaust out of the boat. So we don't care if the boat's submerged. We don't care if there is no air able to get into the boat or out of the boat. And that also unlocks different things you can play with.
Oh, that's kind of a definitely a different aspect. Let's see. So what kind of commercial applications are you thinking? Is it more for like fishing fleets kind of thing?
We're not specifically doing a fishing fleet, but I do see a lot of good entries into fishing. Specifically, I'll just mention one company I talked to. They're building a hydrofoil kind of air dampening assist fishing vessel. And it's really good because this is meant for a fishing farm where the farm is in a set spot. And all they have to do is go back and forth, maintain it, bring fish back on a very set route. The other thing that's nice is that, truthfully, the combustion engines exhaust a lot into the water. As I mentioned, they're using 80 to 100 gallons, even for our small boat. Imagine that at scale in a commercial boat. Yeah. That sometimes goes in the air or sometimes goes straight in the water. Obviously, kind of good to keep exhaust away from your farming wildlife. So that marriage of technology, I think that company has found a really good fit for fishing specifically.
Yeah, there's I know of at least one. I think they're lobster fishermen in Maine that are using, and I don't know whose electric boat, but they're starting to use an electric boat to look after their lobster traps and things like that. So that's a niche that's beginning to develop.
Yeah, and it's great. It doesn't, the low signature noise is also nice. You don't kind of scare away other fish. You don't kind of. So other thing that happened like in marine is, there's a lot of studies about the impact of boat pollution noise, just noise in itself, basically spreading out wildlife from reefs where, they're actually supposed to live in reefs and populate in reefs. But if you're scaring away the wildlife and they go away, and then the tourists go away because they're having more fish, and then also the population gets affected. And there's also stress increases in the wildlife from noisier boats. So I think a lot of these things kind of inherently, are beneficial.
Okay.
I think most of what we've reported on that's been in electric boats, almost everything's been a ferry, hasn't it?
Pretty much.
That wasn't really a ferry.
No, there are some electric tugs now that are starting to appear. I think down the Long Beach area, possibly up in the Seattle area. I know Seattle, of course, they're really focused on electric ferries, Then there's this big new one that's being built down off of in Tasmania. Enormous thing they're building for the ferry service to link, I think it's Paraguay and Argentina. What's that, the River Plate area, something like that?
Yeah. I'm just saying, I don't think we've ever covered anything that was just electric. We've had sailboats, you know,
and we've had parasail boats.
Yeah. But this is the first time we've actually talked about just electric boating in general. So,
great.
This is fun. And so what brought you guys, so you're in Michigan, right? And is that because you got seeded by somebody, or did you get funded by somebody in Michigan? What drove you to Michigan?
When we started the company, we were looking for states that were aligned with our charter, but also aligned to large-scale manufacturing. Michigan has a lot of assets, from the automotive industry, actually, tooling, facilities, electric powertrain engineers. We started talking to the state about what we're doing. They're like, hey, this is very interesting. These are the type of companies we want in the state. Started doing a grant competition with them, and then things started to roll, and like, hey, this makes sense. So we did locate one of our legal headquarters in Michigan. We have a manufacturing location there. There's a lot of benefits to pulling from automotive, ecosystem. So that made sense to us. We have some presence in Austin, Texas, a lot of tech hub happening there. We have a lot of people in California. We're getting more involved with other states like Florida and some other ones. But we're finding there's really good pockets in the U.S. that have a lot of these kind of pieces that a company needs over time. And they've been so fortunate to open their arms and invite us in and help us through this journey.
Very nice. Very nice. Yeah, there's lots of places that have various tax incentives and will train your employees, things like that. I had something else I wanted to ask about.
Can we talk about cost here for a minute? I mean, if you've got an 80-gallon gasoline tank, only takes minutes to refuel it at some marina. What are your costs and time to recharge a battery? Just one of the 150 kilowatt batteries. What are you doing in that area?
Yeah, sort of on an average operation day, and then over kind of a maintenance year, we're about 1/3 the cost to operate over a gas equivalent boat. And I say equivalent because it also depends on the use case, right? Like some of the boats out there will take 180 gallons a day to use. Some of them will take 20 gallons a day. But we'll just be basically, the easy math is roughly 1/3 of that in energy cost to your fuel tank. And the maintenance cost significantly improves. A lot of the consumer boats that you just saw, they cost about $1,500 every 40 to 50 hours of maintenance. Our maintenance per year is go check the coolant level and make sure that it's full. So we cut out thousands and thousands of dollars of maintenance a year. We also don't need to winterize the boat because we have no oil, we have no water intake to the cooling blocks, etc. So a lot of these typical electric vehicle maintenance advantages carry over directly to electric boats. That's all good for the customer. That's all good for the use case. From a charging perspective, it depends. So we'll support level 2 charging to level 3. So you do the math on C rate. Really depends on the amperage you have. Kind of our maximum charge time for the whole boat, the whole 300 kilowatt hours, is charge it over 8 to 12 hours overnight at a 50 to 80 circuit. Those level 2 chargers are coming out and pretty common nowadays. The other thing about this industry is that's fairly acceptable because you take your boat out on a Saturday, store it overnight, or you dock it overnight, and if it is perfectly fine the next morning, you're good. If not, if you go to work for a whole week, you kind of don't care that it's charging.
Right.
So we found that this industry is a little bit more forgiving on charge times, just because boats are more of a pleasure craft type of use case, at least on the consumer side. Fast charging, it depends on the fast charger, right? You have some chargers out there that you do really fast capabilities if you can drive to one. There's other charging networks like Aqua Superpower. That seems really good. They're building a network of fast chargers that's deployed already a lot in Europe and spreading in the US, but that will actually give you level 3 at the dock, which is really cool too.
Oh, at the dock. Okay. Because I was going to ask you, do you have to I could see somebody running around on a Saturday, a weekend, something like that, pulling the boat out, towing it back home. Do they go to the local Tesla supercharger? I mean, what kind of, talk also, look a little bit about the connections that you guys use using CSS or, what?
We're using CCS today. We'll eventually probably move to NACS. It depends on like what's the most common, connector out there at the point. We have a charger is this big, and we can use any charger in the industry, 30 amps or above. Plug it into an EMI outlet and plug it in the boat. Have electrician wire it properly, and you can electrify basically any dock. The other thing about marinas is a lot of them already have these NEMA connectors. It's called the shore power.
Okay.
Because a lot of the bigger boats, most of the time are required to be plugged in the whole time because they have other systems running, like the refrigerators.
Right.
Some of the mariners require them to be plugged in all the time because they want their bilges to operate 24/7 in the case there's a big leak, so that the boat doesn't sink or the boat doesn't drag to the dock. So a lot of the larger marinas with bigger cruiser boats already have these plugs right out the dock. Okay. You just plug, our charger into it or industry standard charger, and then you have level 2 charging. Aqua Superpower has level 3 charging networks. They deploy them as their business model at scale and infrastructure wise, and then you just pay the charging network. And so that's a kind of a nice marriage too that we're seeing in the ecosystem develop.
So how do the economics at this point of the electric boats compare, and where do you see that going in the next, say, 3 years?
Building the actual boat and selling it to market is still a little bit more expensive than where we want to be at. I think where the consumers expect it. That always kind of happens, when you're a new industry building low volume of anything, right? The first volume, the first model is always more expensive than other previous models. That's kind of where we're at today because we're a brand new company. We're building low volumes at the start. As we get higher volumes in production and models out in the market, we'll be working down our MSRPs. And then inherently, we'll get net neutral cost at an MSRP level to the combustion engine market. But then the tipping point is we'll be 1/3 the cost to operate per day and maintain. And then the math makes sense. You just effectively have a very nice option at a lower cost price point.
So, I'm sure as you've been doing this, you've noticed how much the price of batteries has plummeted. And it's certainly made what you're doing far more appealing, especially when you have a 300 kilowatt hour battery and, you see that price, cutting in half every 2 to 3 years. And because I assume that's in producing the boat, that's probably still just like on a car, that's the most expensive part, right?
Yeah. And as I mentioned, the automotive industry is really driving a lot of these cost improvements, technology improvements, battery chemistry improvements. And what's nice about Marine is Marine's always able to adopt that, usually at a 10-year delta. We're moving faster than that now. But that advantage, David, to your point, is going to benefit us, it's going to benefit the customers, it's going to benefit scale. And the cost curve, I have not seen a bottom yet, but it's very encouraging where the cost curve is going on battery chemistries.
Are your battery supplier, can you talk a little bit about that? Are they being sourced here in the U.S.? Are they being sourced overseas? What's happening there? And I assume these are all lithium ion type cells.
Yeah, we have a non-China specific cell supplier that we're very happy with. They have a really good cell, one of the best in the world, I'd say. And we're using that cell specifically because the energy demand for our application is pretty hungry on current and amperage.
Okay.
It's the same cell a lot of EV tools use, for example. And that's how we're able to pack in 300 kilowatt hours in a fairly condensed footprint of 24 feet long. That's today's technology. There's a lot of new stuff coming up. We're apprised of and talking to all the cell providers on new chemistries coming out there. We don't make our own cell today, so we depend on the industry to improve that.
So at CES this year, you guys made an announcement of acquiring somebody. Do you want to talk about that?
I don't know if we did. Actually.
Did you acquire Crewless Marine?
No, that wasn't us.
That wasn't you guys. Oh, my bad. There was something that came up in my research.
You had me worried for a second there because I have some of those conversations happening. I was like, wait, what leaked?
Okay. Let's see here.
So who are your competitors at this point? I know there's Candela over in Sweden. There's Arc Boat. There's Navir or something like that. Where do you guys fit in the mix of up and coming e-boat companies?
In all kind of preference, like we don't really view competition as the right word for this industry yet, or maybe in the infancy, because everyone's still very new. Okay. I'd say it's like, where do the players play, and then where are they going, and then how they kind of overlap, right?
Right.
And so, like Candela, for one, I've talked to some of those early founding investors of Candela. They have some amazing technology. We've actually talked to them about potentially collaborating with their technology when and if we do a hydroflow boat. To your other question. We've also, talked to some of the earlier team in Navier, and I think they're doing some good things because they're really proving out like a larger, enclosed cabin for hydroflow boat. What I like about what they're doing is that they're proving a different way to optimize electric powertrains, because hydroflowing is very different, right? Hydroflowing is all about reducing basically like the friction of the water on the hull.
Right.
Flying the boat out of it, you get an amazing efficiency at range and speed. The one drawback about hydroflowing is you need to really worry about your weight to get up above the water. So there's trade-offs, right? But there's a huge advantage because that is one of the most efficient uses of power, like on a surface level, for transportation on water. So they're doing some cool stuff. Arc Boats, I'd say their first boat in at least their first consumer boat, because they had a different one before the Arc Sport, are in the same market. We're both going after electric water sports boat. We're both trying to prove out in a very demanding use case that electric powertrains can work. They've had a lot of good success.
Or is it me again?
Oh, sorry.
Lose your audio, Bill. Yeah, Bill, every now and then, and it seems to be like a system memory issue on his computer, he sometimes will just lose the ability to hear us.
Nice.
We can hear him if he talks, but he can't hear us, and so he has to leave the studio and come back, and he just looks frustrated, which makes for interesting comic relief sometimes. It's hard to have all this technology working properly all the time, so you just never know. Let's see.
This is a pretty cool studio app, though. I've never been in one of these before.
So this works really well. I highly recommend StreamYard. It's it does a lot of things. For starters, not only am I broadcasting on multiple channels, you've probably seen where I've had people from make comments from various platforms, but the local recording feature was unique to it when we started using it, and for follow-up videos, the quality of the local recordings far exceeds what we're doing right now.
Mm-hmm.
So, and we have pretty good video on the stream right now, but even when the recording is far higher quality, so it really makes a big difference when we make clips and things out of it. So yeah, I like it by far the most. We've tried others, and we settle on this. And this one actually is a little more complicated to use. Some of the other ones are a little more simplistic to use, but this one just gave us features we really had to have. So
yeah, that's great.
Yeah, so that's where we're going. Bill, can you hear us now?
I'm back. Yeah.
Okay. Well, that happens. That happens.
About once every other broadcast, it seems.
So, what are you hoping to accomplish here in the next couple of years?
Get our consumer model to scale. We have a new market segment that will launch mid this year at another show. We want to get these fielded and then good, solid production maturity with our dealers. And then we want to show you a full edge to grid solution, which I won't talk a lot about, but the whole philosophy here is it's not actually just about boats for our company. It's actually about energy transfer. So, we're moving to a new world where, Bill, you've kind of been a part of this, even before my time. It's not just about the vehicles and mobility. It's actually about how the world's using energy in different use cases. And you have energy used at the edge. You have energy used at the infrastructure level. How we go marriage those things and network them together and load balance across the world is going to be the next unlock.
All right.
Where energy is going.
So let me ask you a question. Let's say I buy one of your boats and I park it in San Francisco, and I've got a V2G set up somehow. Can I arbitrage energy there in California with my 300 kilowatt hour battery and make money with my boat?
Oh, there you go.
There are hardware that can do that, and there's software that can do it as long as the utility's set up for it. Yes.
Yeah, because I know people are doing that in California with battery energy storage systems.
Yeah.
Of course, that's a much larger, setup, but still, because we talk about V2G and how realistic is it really? I mean, obviously, we see the battery energy storage systems doing it, on a large scale, and people are doing that now just so they can arbitrage buying energy at night in California and reselling it during the day in California. And I could see you doing that in Nevada too, because Nevada's the same way. They have free energy at night for certain applications. I'm just sitting here thinking, it's like, man, that's a big damn battery. So, we talk about, so it's the same size that you put in a school bus, right? Yeah. But with a school bus, you typically have it goes to just the elementary kids, then it does the middle school kids, then it does the high school kids, takes a few hours break, and it goes and it charges, and then it goes and reverses course in the afternoon. And then it goes and it can charge overnight, but you could use the excess battery for arbitraging. But by the time you finished your route for the day, that 300 kilowatt hour battery may have used half of it, right? But in your case, most people aren't using their boat that much, right? They're using it a few hours a week. And so you've got that opportunity, man, you really could be using that 300 kilowatt hour for arbitraging energy. I'm just curious what that economics of that might look like.
I think this is huge. You're using your vehicle, 100 to 300 days, depending on who you are, a day or a year. And that is an automotive grade battery cell, right? So it has a standard industry life expectancy of 8 to 10 years. The average boat user in the US uses their boat 45 days of the year. We're using automotive grade battery cells that are expected to get 8 to 10 years at a heavier duty usage cycle per year. So you can go use those cycles for V2G aspects. And as we discussed earlier, like David, you take your boat out on Saturday, you're going to work Monday through Friday, maybe, or maybe you'll get another boat day in between then. You can program your boat to say, hey, these days, I don't care what you do. Go load balance with the grid, go make some money, go charge during peak cycles on cost, and then offload to the grid whenever we get paid for it. But it's also 300 kilowatt hours. So these type of vehicles at the edge are a whole different use case than what we've really seen in those other industries, because land vehicles are heavily used on a routine basis. These are heavily used like once a week.
Yeah. So obviously you've thought about this. You don't want to talk about it too much.
V2G, definitely on our roadmap. It's such a good use case for boats. It's incredible. Some of these boats get stored inside, right? So they're just in a nice environmentally controlled, warehouse or shed or storage unit, and it's going to be plugged into the same level 2 type charging capability just as any vehicle. You don't really need battery energy storage, in some cases. Like battery energy storage is just a big battery on the grid. These are big batteries that are mobile, but I do believe eventually we need to make sure that the grid is edge to grid infrastructure. V2G is going to unlock a lot of cool use cases for the world.
Yeah. I'm always looking at everything from the economic lens. Bill and I talk a lot about stuff in the EV space. We all want to save the planet and all that, but until you have applications that financially make sense for most people, and especially for businesses, it's hard to make the switch. And when something costs 50% or 300% the cost to try to go green, people just don't get that motivated. And we've got something like the V2G aspect and could pay, prospectively might cover a huge chunk of the cost of your boat. That's pretty attractive.
Worth considering. Yeah.
I think eventually cover portions of the cost of your boat, but it's also going to cover all your usage.
Yeah.
Right. Like people are buying $100 a day in gas just to go out and putt around the lake. You won't have to pay for that eventually in electric boats.
Yeah, that's a pretty big savings. All right. Anyways, we're running out of time. So, anyways, folks, I want to thank everybody for watching today. Richard, I want to thank you for coming on.
Thank you.
I'm going to go ahead and end the stream. Bill and I will be back on Tuesday.